The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example ionic radius. Which element has an ionic radius that is smaller than its atomic radius? To really understand this question, what we're first going to need to do is really figure out what an ionic radius is, and in order to do so, it's a good idea for us to look at valence shells, valence electrons, and various trends that take place on the periodic table. And we'll talk about ions and ionic charges as well. So let's do that first, and then we'll come back to our question. Looking here at figure 1.2, as we see here, the elements on the periodic table all have partially filled outermost shells except for our noble gases. Now, if we take a look here at group 1 is going to have one valence electron in its outermost shell. And what is a valence electron? Let's just do a quick definition here, and then we'll get back to our slide. A valence electron is an electron of an atom located in the outermost shell, the valence shell of the atom. Now, Group 1 elements have one valence electron. Group 2 elements have two valence electrons. Don't worry about the transition metals. This block here, we'll cover it when we need to, and it's not really going to be related too much into the type of questions you're going to be coming across. Now, the third main group, as we see here, has three valence electrons. The fourth main group has four valence electrons, the fifth group has 5 valence electrons, 6 valence electrons, and 7 valence electrons. Now, one other point that I would like to make about the noble gases is the helium atom is the only one here that has 2 electrons in its outermost shell, and the rest of the noble gases here, they have 8 electrons in their outermost shell. Now, these atoms, right, they want to get that filled outermost shell, as we see here, for our noble gases. Now, there's one of two ways that an atom can do that. It can either gain an electron or it can lose an electron. And when an atom gains or loses an electron, it is then considered to be an ion. Furthermore, from the element's position on the periodic table, we can determine whether or not it's actually going to gain or lose an electron. Let's take a look at that now. Looking here at group 1, group 1 is going to lose one electron, that one valence electron it had. Group 2 is going to lose 2 valence electrons. Group 3 is going to lose 3 valence electrons. And group 4 can either gain or lose 4 valence electrons. Now, Group 5 is going to gain 3 electrons. Group 6 would rather gain 2 electrons, and Group 7 is going to gain 1 electron. Now, to further elucidate our point, let's take a little bit of a deeper look at that. More specifically, we'll take a look at the fluorine atom in Group 7. If we take a look at fluorine here in figure 1.3 down here, we see that fluorine has how many? It has 7 valence electrons, right? 1, 2, 3, 4, 5, 6, 7. Now, this fluorine atom can either lose 7 electrons, right? Or it can gain an electron. It's going to gain that 1 electron, right? Now, when fluorine gains that electron, it is then considered, that fluorine atom gains that electron, it is then considered to be a fluoride ion. And that fluoride ion is going to carry with it a negative charge. It's going to carry with it a negative charge. Now, if we come back up here to figure 1.2, we see that it's going to have that. We see all elements here, right, in group 7, right, when they gain an electron, they're going to have a -1 charge. And what is that -1 charge telling us? The -1 charge here, it's telling us that it's going to have one more electron than proton. Now, similarly with group 6, in order to obtain that arrangement, right, that full arrangement, it's going to gain 2 electrons, giving it a -2 charge, meaning it's going to have 2 more electrons than protons. Same thing for group 3. It's going to gain 3 electrons, giving it a -3 charge, meaning it has 3 electrons. Excuse me, it has a -3 charge because it has 3 additional electrons. It's 3 more electrons than protons. Now, let's contrast these ions over here, right, with the ions in group 1 and 2 that actually are going to be going to be giving up an electron relative to gaining an electron, as we had just seen. More specifically, we'll take a look at sodium here. We'll take a look at sodium. Now, in figure 1.3, right, if we take a look at sodium here, we see that sodium has one valence electron, right? And recall we said that group 1 elements have one valence electron. So sodium, it can either give up that one electron, right, or it can gain a bunch of electrons. Now, it's going to give up that one electron, and when sodium gives up that one electron, it's going to become a sodium ion, as we see here, right? It's going to become a sodium ion, and it's going to have a positive charge, right? Thus, if we come back up here, we see that group 1 elements such as sodium, they're going to have a positive charge upon giving up their electron, indicating to us that it's going to have one more proton than electron. And similarly for group 2 elements, as we see here, it's going to give up 2 electrons and give up 3 electrons here in group 3. Now that we understand how valence electrons work, what the tendencies are of the different groups, right? And recall earlier we said that elements within a group, right, they have similar chemical properties, right? So now that we know which elements are more likely to give up electrons, right, and which elements are more likely to gain electrons, let's use that knowledge and see what happens when an element either gives up an electron, what happens to this ionic or atomic radius, right, or we can say the atomic size here, right, or what happens to that ionic or atomic radius when it gains an electron. Let's see how that impacts either how it will impact the element on the next slide. Let's take a look at that. Now, looking here at our now, before we proceed, recall we had just said the atomic radius, once the atom gives up or gains an electron, or gives up an electron, right, or loses an electron, we can say, then we are referring to its ionic radius. Now, coming here to number 1, we see that if no protons are added but an electron is removed from the atom, the radius of the atom will increase or decrease. Now, before we move on to that, let's consider this for a second. We have to recall that electrons, they have repulsive forces, right? And electrons, in contrast, an electron and a proton have attractive forces. Now, coming back here, if no protons are added, we're not changing the attractive force, right? But an electron is what? It's removed, right? The electron is removed. And if the electron is removed from the atom, what's happening is we're taking away repulsive forces. So if we take away repulsive forces, then that atomic radius is going to decrease, right? Thus, we can then say that if no protons are added, but an electron is removed from the atom, the radius of the atom will decrease. Now, how about in number 2? Let's take a look at this scenario. If no protons are added, but an electron is added to the atom, the radius of the atom will increase or decrease. Now, once again, we see that there's no change with the attractive force, right? But what's happening with the electrons? There's an electron that's being, excuse me, let me just make that consistent, but an electron is being added to the atom. Now, if we add an electron to the atom, it's going to push those electrons farther from the nucleus, right? Thus, if it's going to push those electrons farther from the nucleus, then that's going to increase, that atomic radius, right? And if it increases that atomic radius or ionic radius, we can say, all right, if no protons are added, but an electron is added to the atom, right, the radius of the atom will increase. Okay, great. Now, one other term that I would like to introduce to you before we move on is what is known as the effective nuclear charge. Let's actually proceed to the next slide, and we'll talk a little bit more about this there. Here we are. Effective nuclear charge. Now, if we look here at figure 1.5, we see that these outer electrons,